Hi, thank you for joining me. My name is Robert Kaplinsky, and I'm looking forward to talking to you about digging into depth of knowledge. Now, whether you teach in a Common Core state or not, we all want students to have this rigorous understanding. And the Common Core authors define rigor as having deep, authentic command of mathematical concepts, not making math harder or introducing topics at earlier grades. Now, I want you to think for a second of a student who is one of the most talented students you've ever taught. I want you to picture that student in your mind. What do they do to challenge that student? Sometimes you see that those students receive maybe extra work. Here's some additional problems or some work you can do at home. Sometimes they skip them to the next topic or keep them in the same grade but give them work from future grades. And they're specifically talking about how rigor isn't about that it's not just making the math harder. So then how do we actually accomplish this rigorous understanding? Well, they talk about there are three aspects of rigor: conceptual understanding, procedural skills and fluency, and application. And that we want to have an equal intensity of each of those, which doesn't mean equal days, but it used to be that there was this overemphasis on procedural skills and fluency, like that was the only thing that mattered on standardized tests. And now there's a conscious effort to balance that with some ability to apply it and understand why it works as well. So I want to explore what deep authentic command looks like, because until we've actually seen what we're looking for, it's really hard to know how to achieve it. And to explore it, I want to explore it with this fourth grade standard, applying the area and perimeter formulas for rectangles in real-world and mathematical problems. So take a look at this problem. What is the perimeter of a rectangle that measures 8 units by 4 units? I don't think anyone sees this and thinks, wow, this is an amazing problem. I think it looks rather typical. So let's watch a student answering this problem and see how the student does. What is the perimeter of a rectangle that measures 8 units by 4 units? Okay, how do you know?
Because when you're solving perimeter, you're supposed to add all the sides up.
So there are those three components of rigor: procedural skill and fluency, and conceptual understanding, and application. Now this isn't really an application problem, so we're really going to focus on just procedural skill and fluency and conceptual understanding. Now the question I have is whether or not the student demonstrated procedural skill and fluency and conceptual understanding on the problem that we just saw. I'm going to make the case that yes, the student demonstrated procedural skill and fluency. The student knew that you needed to add all 4 sides together. And I think the student had conceptual understanding, demonstrated that he needed to know the length of the 4 sides because the length around the rectangle would give him the perimeter. So now, my question is, if this is what we're seeing, does this measure deep authentic command? Is that what the student is demonstrating? Somehow it doesn't feel that way, so I wanted to dig a little bit deeper. I next asked the student this question. List the dimensions of a rectangle with a perimeter of 24 units. Now it's important to realize the standard hasn't changed at all. We're still asking stuff around the area and perimeter of rectangles. But somehow we also know that the problem is a little bit different. So let's watch the same student seconds later answering the same problem. List the dimensions of a rectangle with a perimeter of 24 units. Okay, and how long are the other sides?
The other sides will be smaller than this number because.
So this side is 24 units long?
Yeah.
And then how long is this side?
24.
And how long are these sides?
You'd say about 18 units.
Can you label them, please? Okay, thank you very much. So, same student we just said had procedural skill and fluency and conceptual understanding. I'm not sure you feel the same anymore. I don't think the student demonstrated procedural skill and fluency with this particular problem, nor conceptual understanding. It seemed like all that feeling that we had before had gone away. So the question I have is why? What I'm going to say and try to make the case for you is that the first problem that we asked the student was depth of knowledge level 1. And the second question we asked the student was depth of knowledge level 2. And increasing the depth of knowledge that little bit was enough to show us that there were some serious gaps in the student's understanding. But maybe it's just that one student. So let's look at a second student answering the same first problem. What is the perimeter of a rectangle that measures 8 units by 4 units? So 24 units? Okay, thank you. So again, it seems like the student has procedural skill and fluency and conceptual understanding, but let's dig a little bit deeper and ask the student the same second question. List the dimensions of a rectangle with a perimeter of 24 units. So large. Yeah, so I'm not sure that we're seeing procedural skill and fluency here anymore, nor conceptual understanding. And it's worth reflecting on why this is happening and how did we come to get to a place where this could be. If you think about it, it really isn't that surprising. I'm in California, so the standardized tests that we used to have prior to Common Core, the kinds of questions they asked look like this. This is a release test question from our outgoing standardized assessment. It says a basketball court is shaped like a rectangle 20 meters long and 10 meters wide. What is the perimeter in meters of the court? And I think the scary reality that we all realize is both of these kids will get this problem right. And these questions, when they answer them correctly, they measure proficient or advanced on the state test. But now we start to see that this was giving us a false positive measure of their understanding. Kids could get this right, but not really understand what they were doing and not have that conceptual understanding. And this is a really scary place to be. So I want to look at one last student doing the same first and second problems. What is the perimeter of a rectangle that measures 8 units by 4 units? How do you know that? So you're probably a little skeptical of marking off procedural skill and fluency and conceptual understanding, but I'd make the case that based on the problem that we just gave the student, it seemed like he did demonstrate procedural skill and fluency and conceptual understanding. But let's watch the same second problem now. List the dimensions of a rectangle with a perimeter of 24 units. So how do you know that 10 and 2 will give you a rectangle that has a perimeter of 24 units? So when you add them, what happens?
It is 24.
24. Okay. Finally, right? So procedural skill and fluency, seems like he demonstrated that. Conceptual understanding, it seemed like he understood that you add up the lengths of all the sides. So this must be what deep authentic command looks like, because the student has that conceptual understanding of procedural skill and fluency, right? I wasn't really sure. I was thinking, could this really be as deep as it gets? So I decided to ask the student one more question. Of all the rectangles with a perimeter of 24 units, which one has the most area? Now, what's important to realize is that this problem is still measuring the same standard. Apply the area and perimeter formulas to rectangles in real-world and mathematical problems. But simultaneously, I think we realize that even though this is a fourth grade problem, the answer doesn't immediately pop out. So I'm going to give you about 30 seconds to think about what you think the answer is, and then I'm going to show you how that same third student responded. Now, there are at least 3 ways to approach this problem. One would be a pure guess and check. I'm talking like throwing darts at a board of numbers. And eventually you might hit it, but there are a lot of different rectangles here, depending on whether you define the rectangles to have whole number sides only. But if you could have fraction lengths of sides, then there's an infinite number of rectangles. So a pure guess and check strategy wouldn't work very well. You might start kind of doing a guess and check strategy combined with maybe noticing patterns. And what you might start to notice is that when the two measures, the length and say the width, are closer together, the area increases. Which leads to the third strategy, which would be conceptual understanding. And you start to realize that as the rectangle approaches a square, the area increases even though the perimeter stays the same. So the ideal rectangle would be the square with side length 6 and give you an area of 36. So again, the standard hasn't changed, but let's watch the same student solve this problem. Notice a timer in the top right. Of all the rectangles with a perimeter of 24 units, which one has the most area? Of all the rectangles with a perimeter of 24 units, which one has the most area? That's what you think? Okay, thank you very much. So, procedural skill and fluency? Well, when we gave him this problem, it didn't seem like it, but consider that we just said after the first two problems that the student did demonstrate procedural skill and fluency and conceptual understanding. Now, what happened to that? Conceptual understanding? Where did that go? Seems like it's not there at all. So, I wanted to find the problem so we can figure out how we're going to solve it. The issue, as I see it, is that students appear to demonstrate deep, authentic command of mathematical concepts when we give them these commonly used problems. However, with more challenging problems, the same students seem to no longer demonstrate that command. So here's how I plan to address this. First, we need to have a clear understanding about why these problems are different from one another. Next, we need to get practice using these problems so that we can understand how students may react to them. Finally, we need a source that can provide us with a variety of free problems. Now, to get us warmed up, I'm going to give you guys a problem, and I'll give you 4 minutes to do it. The problem is a 5th grade adding decimals problem. Use the numbers 1 through 9 exactly one time each to fill in the boxes and make 3 decimals whose sum is as close to 1 as possible. Feel free to use a calculator with this one, and you can put, say, 0 and 987 thousandths, so 0.987 plus 0.654 plus 0 plus 0.321 and add it together. You want that sum to be as close to 1 as possible. In general, it takes at least 3 or 4 attempts to figure it out. I'm going to give you 4 minutes and then we'll check back in together. You notice that at the bottom, the little zigzag lines will switch from blue to green as it approaches 4 minutes. Now, you probably haven't had enough time to actually finish the problem, but you probably have had enough time to get a feel for what it's like. I'll be sharing a link to the answer to this problem if you're really curious about what it is. But I hope at this point you kind of start to get a feeling of, these problems are accessible and that really anyone could try them, but they're also really challenging because the closer that you get to one, the harder it is to make little adjustments that will get you closer but not too far. Now, I've got a lot of problems like this, in fact. Um, some of you may be familiar with my depth of knowledge matrices. This matrix goes from kindergarten through 5th grade. I've got another one for secondary math that goes from 6th grade through calculus. And then I've got one that's a general purpose one that's for elementary and secondary. That example has examples from elementary school, middle, and high school. So we won't have time to go into this in depth in this presentation, but I wanted to give you a little taste of what it looks like. And then you'll be able to download it as a free PDF and then share it and use it and spend some time with it. So there are columns on each side. On the front side, we've got kindergarten, 2 for 1st grade and 1 for 2nd grade. The back side has 2 for 3rd grade, 1 from 4th, and 1 from 5th. Now you'll notice that in each column, it's a single topic. I've seen a lot of different charts that show, say, a depth of knowledge 1 example with adding 2-digit numbers, a depth of knowledge level 2 with operations with time, and say a depth of knowledge level 3 with comparing fractions. But when the different problems are so different, it makes it really hard to compare the nuances. What I like about this is that it's the same topic, and you can see what it looks like at depth of knowledge level 1, 2, and 3. So feel free to look at this again. You've got kindergarten through 1st grade and 2nd grade on the front, and then 3rd through 5th on the back. And again, you can download that and use that and look at it at your leisure. What I want to talk about now is this idea about complex or complicated. Maybe you've heard both these terms used interchangeably. I know I used to use them interchangeably. I would say like, wow, that's a really complex problem that you have. Or that's a really complicated problem that you have. And not really think about what the differences between them were. But now I see them as very different. I want to talk about why that is. Consider the differences between raising a child and sending a rocket into space. Both are considered difficult, but they're difficult for different reasons. When you send a rocket into space, there are a long list of procedures that you have to follow, but if you follow them accurately, you can reliably repeat the process over and over. I mean, it's gotten to the point where sending rockets into space is trivial, no one pays attention to them, but when it first happened, it was the most amazing thing. Now, things happen, but you can account for them. For example, if it's cold, do this. If it's warm, do this. If this sensor goes off, do this. So things happen, but you can account for these variables. And that's what makes sending a rocket into space complicated. Raising a child, on the other hand, is complex. Even if you were parent of the year for child number 1, and you wrote down everything that you did, by the time it gets to child number 2, that child's so different that you couldn't possibly hope to follow those procedures and get anywhere sort of close to the results you have with child number 1. That's because there are so many variables with children that you can't account for. And that, again, that's what makes it complex, because complex situations have variables that you can't really account for, while complicated don't. But this isn't the only place where this happens. Have you heard of Pinterest? Pinterest is a website where you share kind of beautiful images with people that inspire you. For example, let's say you're having a kid's birthday party and you see these Cookie Monster cupcakes. So you say, wow, this is amazing. I would love to make these for my kids because they would be so excited to have them. But when you make them, it doesn't always come out the way you hoped, and sometimes it comes out looking like this. I mean, I think this is more likely to inspire nightmares than it is to inspire kids who are excited about their dessert. And if you think about it, how does this happen? I mean, it should be so easy, right? All you have to do is follow these 8 simple steps. But you probably hear the sarcasm in my voice. Just following these 8 steps is not enough. This is because they're treating baking like it's complicated when it's really complex. There's no mention about, say, the temperature of the cupcakes, the temperature of the room, the temperature of the frosting, what altitude you're at, what the ratio of sugar to water is in the icing. If you don't talk about these things, well, you're not going to get anywhere close to where you want to be. But the reality is that there are so many variables that are really hard to account for when you're baking because it's really complex. But the reality is that it doesn't stop people from treating it like it's complicated. So the important thing here is that there are complex situations treated like it's complicated, and sometimes the results are disastrous or hilarious depending on how you look at it. And so when someone hands us a resource, we use it. Because what else are we going to do? We don't have time to go and search and research and verify that this is the best way to do it. So I'm going to share with you some examples that are pretty commonly used, not because I want to make anyone feel bad, because guess what? I've used them too. I've shared them as well. But with more time to think about it and reflect on it, I wonder if it really is going to get us the results that we want. So, again, take it with a grain of salt. Don't feel bad if you've used it, but now let's start thinking about whether it's the best way forward. The first example, perhaps the most common, is this DOK verb wheel. The basic idea would be that if you want to encourage students to use a certain depth of knowledge level, then use that verb in the task that you assign. For example, modify a task modify a problem would be depth of knowledge level 2, or asking students to create something would be depth of knowledge level 4. But you start to see problems in there. For example, construct and compare are in both depth of knowledge level 2 and level 3. And somehow it doesn't really feel like these verbs are going to get us the results that we like. If you do that, if you play around with that chart that I showed you, the DOK matrix, you'll see that it doesn't really match up well with this. And so what we start to think about when we learn, I researched the root of this particular verb wheel, and Norm Webb, the man who invented depth of knowledge, he basically says, and I'm paraphrasing heavily here, he basically says that it's really time consuming to identify a task DOK level. So it might be easier to start with using the verbs and identifying the verbs. But he never says that this is the ideal or best way. So I get why people are using this, but I don't think it's going to get you the results that you're looking for. Next, I have this DOK flowchart. I saw this in a presentation at a conference I was at. And again, I'm sure that this has the best intention, but I'm concerned that someone receiving this without really deeper thinking about it will be set up for failure. For example, look at the pathway for DOK3. It begins with, is there a right or wrong answer? Which is a little confusing to me. I think Tracy means, are there multiple answers? But let's assume the answer is no. Then the next question is this a question or task that is new or fairly new to students? The answer is yes. Well, now you're doing DOK3. And in my mind, if I just saw this and I didn't know anything else, I would just think, well, I should be doing DOK3 all the time, so I'm just going to do tons of new topics, maybe 2 new topics every day, and that way everything will be a DOK3. But again, I don't think it's getting us that deep, authentic command. I think this is getting closer to more topics giving, course for the next work or more problems, and that's not what I want. And now you have these DOK posters. I shared posters just like these on my site, so I'm not saying that I've never thought about these as being great resources. In fact, I think the questions really are great. And the verbs kind of tie back into the verb wheel, which I'm not a big fan of. But what I want to be clear about here is just having great conversations doesn't mean that students are going to have deeper understanding of the mathematical content. So we want to really focus on tasks that help students develop deeper understanding of the math content in addition to having good conversations as well. So if I'm going to judge them, it's only fair that I judge myself. So let me share how I see the differences between the depth of knowledge levels. With DOK1, you've got recall and reproduction, which is often a trivial application of facts, generally requires little effort beyond remembering a formula, and usually only one answer. With DOK level 2, skills and concepts, there's usually more than one step required to solve it, and often multiple answers. But it's with DOK level 3 that's my favorite level. If you think about that adding decimal problem that you had a little chance to think about, it usually requires critical thinking about how to approach a problem. Like you might have just randomly put numbers in there, but then you start thinking, where should I put the numbers so it'll get close to 1 as possible? Like you probably started realizing that putting bigger numbers, bigger digits in the 10th place would result in a sum that's way bigger than 1. So you probably try to figure out a strategy that would balance that out. And again, you're using critical thinking about how to approach the problem before you even began. There may also be multiple answers or a single optimal answer. By optimal, I mean find the smallest, find the biggest, find the closest to one. And probably I should be more precise and say find the least or the greatest. But if you think about the problem that you did with the adding decimals, if I just asked you to find any sum, that would be interesting. But by making it the sum that's as close to one as possible, it changed things and it made it much, much more challenging. And that's a hallmark of DOK level 3. And this may sound silly, but often challenging enough to make your head hurt is again a hallmark of DOK 3, it seems like. Because when you do these problems, it really gets you thinking. And this can make your head hurt in much the same way that when you exercise any muscle, it taxes that muscle and it makes it hurt. Now you might be wondering where DOK4 has been this whole time. Well, this is extended thinking and are generally represented by performance tasks or problem-based lessons. And I have a lot of those on my website under the Lessons tab. So you can check those out too if you're interested. I want to wrap this up by talking about some frequently asked questions. Let me begin with this one. When will students ever use this? I don't get that question a lot when I talk about my real world problems, but I get that with this. Like, this is not something that students will be doing in real life. But the way I respond is like this. Why does anyone go to the gym? Like, for example, why do you do the bench press? Are you ever going to be on your back with something landing on you that's like 100 pounds that you're going to have to lift up in exactly a vertical pattern? No, you do that because it's part of making your body stronger. And when your body is stronger, it contributes to your overall health. Similarly, you're never going to have a situation just like this, but being able to critically think will help you become a better problem solver and help you get out of situations where maybe you're being taken advantage of or when you could find an answer that would be beneficial to you and your well-being. I often also get asked what DOK level I should start students off with. My answer to this is I always start with DOK1, but the important thing is I don't live there. When students can do a DOK1 or a couple DOK1 problems, then I want to move on to DOK2 and DOK3 as quickly as possible. To be clear, this is not how I always did it. I used to do DOK1 and do 20 or 30 problems like this. I mean, that's what the whole textbook seemed to be. And I would just have them repeat the same thing over and over again. And when I reflect back on that, I don't really know what benefit that was giving them. So I will say that some people disagree and think you can start with like a DOK3. But again, go back to the adding decimals problem. If they can't even add decimals, it really makes it hard to do that problem. So once they can start adding decimals, move them along. How do teachers fit these problems in? Where I find them to be ideal is as a replacement for some or all of the classwork that we did with worksheets, where you're doing like 20 or 30 problems. These could also be a homework problem. Consider using that adding decimal problem as the entire math homework. Kids would do so many problems in the course of doing it, I think that they would find that really beneficial. I probably wouldn't put a problem like that on an assessment, maybe one that was closer to DOK1 or 2. That adding decimal problem was DOK3. How do I help prevent students from giving up after trying the problem once or twice? I have a tool called an open middle worksheet. It looks like this. This is the first attempt. There are 6 attempts on each sheet, the 1, 2, and 3 on the front side, and then the 4th, 5th, and 6th attempt on the back side. I tell students that they get 2 points for every attempt and 2 points for each explanation where they explain what they learned from the attempt and how their strategy is going to change on the next attempt. And what happens is that the incentives change from just, if I can't get it right, I should quit to, well, I'm getting more points each time I try it. I should keep trying it as many times as possible. And I'll even joke around and tell students, like, I hope you don't get it right on your first try because you're not going to get as many points as you could. I hope you tried at least a few times. And this really does seem to help them make a difference. And I'll share a student work sample about this in a little bit. Where can I find other DOK2 and DOK3 problems or submit ones I've made? There's a website called Open Middle, which I'll also talk about in just a little bit, but openmiddle.com has hundreds of these. I think it's close to 400 problems now that go from kindergarten through calculus. And if you have ideas for one, you can submit problems there. Like, just think about this. What if one teacher and every school district submitted one problem? We'd be done. We'd have thousands of problems. So something to think about there. I want to end by sharing with you my favorite piece of student work I've ever received. It was a problem where students had to figure out that DOK3, the area of find out the maximum area of a rectangle with a perimeter of 24 units. Now this was an 8th grade student who solved this, and on her first attempt, she couldn't even draw a rectangle that had a perimeter of 24 units. That would normally be the beginning and the end of her experience, but she wanted to get as many points as possible, so she didn't quit. Next, she found a rectangle that did have a perimeter of 24 units and found an area of 32, but she thought there might be another problem, another rectangle that had more area. So she went to 2 by 10. Now you're probably not surprised by 10, right? Bigger number must have a bigger area, except it doesn't. The area was now 20. Undeterred, she tried 1 by 11 and only got an area of 11. It was at this point, though, that I started to realize something. Wow, these kids have procedural understanding of area of rectangle, but they have no conceptual understanding. Like they don't understand that where are the square units are. So I had students come up and draw a rectangle that was 1 by 11 and show where the 11 square units were, and show a rectangle that was 2 by 10 and show where the 20 square units were. And that's where this comment of use numbers with more than one row came from. The students realized that it was better to trade in a column to get an extra row. Now, of course, these rectangles are not drawn to scale, but now she starts to realize a 5 by 7 rectangle is closer, and finally the 6 by 6 gave her the optimal area. And think about this. When we talked about this and reflected on it after the lesson, the kids were beaming with pride. They went from feeling like they were not good at math and should just quit to, wait, I can actually figure this out. It was one of my favorite days in the classroom. So I want to show you now where you can find these resources. Openmiddle.com is a website that I co-founded with Nanette Johnson, and it's supported by Brian Anderson, Dan Luevanos, and Zach Miller. And we've got, again, problems from kinder all the way through high school. You can click here and submit a problem of your own. You can download, you can search for problems right here, either by standard or by topic, and you can download those open middle worksheets here. I'll also show you where you can download them using the link at the end of the video. If you prefer, you can get an email every time there's a new problem. You can subscribe here. And then here's a pro tip for you open middle advanced users. This is my favorite place to actually browse because you can see how many are in the whole grade level and how many are in each part. There are more kindergarten problems now, but this is what it was when I took the screenshot. This is what an individual page looks like. This is the title of the problem, and here's the actual problem itself. How many points are 2 integer coordinates away? I'm sorry, how many points with 2 integer coordinates are 5 units away from -2, 3? If you click on this tab, a hint will open up. It's a hint that doesn't really tell them that much, but gives them enough information to keep going. If they click on this, the answer will appear. Over here is the person who created it, so you can give that person some love and say thank you or ask questions. And down here you see the standard, the depth knowledge level, and a little more information. Thank you for making time to watch this video. Now, if you're interested in the resources, go to robertkaplinsky.com/Iowa. That's robertkaplinsky.com/Iowa. When you go there, you'll have to enter your contact information, and it will take you to the resources page on my website. I'll use your information to send you weekly emails, usually on Tuesdays, when school's in session. These emails have tips that you can use in your classroom right now. And if you're interested in this depth of knowledge topic, I actually have a 6-week online workshop that I offer in the fall and spring, and I'll be sending out more information about it via email. I go deeper into depth of knowledge as well as real-world problem-based learning. Thank you again, and have a great day.